Now let's look at global distribution of mineral exploration. Mineral exploration is being done in several countries and several areas, but the ones that are massive or significant countries that are doing significant exploration include Canada. Canada is one of the countries that is doing a lot of exploration. When you go to Canada, mining is very high in Canada, and also it is high in Australia. Australia is, I think, if not the first, I think it will be among the first countries that engage in mining a lot. Australia. Then we have Latin America. In Latin America, we have Chile, Peru, Mexico. These guys are also into a lot of mining. China is there. China, there are a lot of mining operations in China. When it comes to Africa, we have Ghana. Ghana is one of them. South Africa. South Africa is also should be there in Africa, because when it comes to Africa, South Africa is the leading country in the production of gold, and the production of gold. So South Africa is the leading country. I think Ghana will be second. We have Democratic Republic of Congo. And the United States, a lot of mining operations also going on in the United States. Now let's look at industry trends. What are the trends that are going on in the industry? Focus on critical mining and mineral. Now, it's very important that every exploration that we engage in actually is based on a particular mineral. In Ghana, when you go for documentations or the license to do exploration, you have to specify the kind of mineral you are going to explore in. So let's say you said you want to explore in gold over a particular land. Then you went there, and during your exploration, you realize that the place contains gold and also silver. So the dominant mineral is gold, and the helping one or the accessory is silver. That is recessive one, recessive mineral. Sometimes some companies can decide that they are going to mine both. But because you have already gone for license for only gold, you don't have any right to mine the silver. You mine it alongside the gold, but you cannot do anything with it. You have to throw them away as waste, because you didn't receive the license to explore silver. You receive license to explore gold. Okay. But there are some companies that decided, okay, since you are seeing silver, you can go ahead and take the license to explore silver as well. So it become a multi-mineral processing company. Okay. So increased demand for minerals used in renewable energy technology, electrical vehicles, and other green technologies. And in today's world, materials or minerals that can produce energy for us are the ones that have become the focus for exploration. Okay, although gold is good, and a lot of companies or countries demand gold, but when you compare the mineral that is in high demand because of its use in the energy sector is coal. So when you go to the US, most of the companies they explore coal and they mine coal. So when you go to Australia, US, even China, they explore a lot of coal. Okay, so we have to look at the mineral of interest. What is the mineral that is in high demand? So when it is in high demand, then we can focus our attention on. But in Ghana, we don't have a choice, because the mineral we have in abundance is gold. So we just go ahead and explore gold, because gold is also in high demand around the world. The next one is exploration in more challenging environments. Increasingly exploring in deeper more remote and environmentally sensitive areas. In those days, it was difficult to explore in dangerous areas, but today, by the advent of technology, we can now enter into dangerous areas and areas where it's very difficult to go because maybe the machineries we are going to use, the drill rig cannot access such areas. But by the help of technology, geophysical technologies can help us to assess the presence of mineral in such areas. With, by the use of electromagnetic technology or magnetic technology, sometimes seismic waves, we can be able to explore certain areas without the use of drillers or drillers in such areas. Use of big data and AI. Now, leveraging large data sets and artificial intelligence to improve exploration efficiency and target generation. So now AI is the new technology on board now, and with a good understanding of the subject, you can apply it in several things, including the mining industry. And in the mining industry, it's already being used, and you can also apply it in exploration. Why drill? So the question is, why must we drill? Why drilling? Because drilling is very, very expensive. Before you decide to drill, maybe we don't have the equipment, so we need to go and rent. Sometimes even getting the equipment to rent is very, very difficult. You need to go and rent. You have to queue in your line until it reaches your turn, then you can rent. Okay. When you rent, you need to fuel the, the machinery. You need to employ people to do. Sometimes they even pay based on meter drill, a meter drill. And I think currently is around $50 per meter drill, or 50 to, no, 50 is too small. I know when you're considering uh, diamond drill, you can pay about $200 per meter drill. But ounces are around $50 to $100 per meter drill. Very expensive. And imagine if you are drilling 1,000 meters per hole. Why must we drill? Drilling provides only direct way to assess and sample the subsurface geology. We want to know what is going on within below the surface. How does the rock structure look like? We want to get this information. What is the mineralization within the subsurface? So this information will help us to know how to make our decisions. We don't want to make decisions offhand. We want to have proper information to make the right decision. Okay, so it is the drilling that will help us obtain sampling, which we will take to the lab, analyze it to obtain certain information about the rock formation. Then you know what type of rock you are drilling, what is the mineralization. Get it? Then drilling confirms or refutes surface geological and geophysical interpretations. It is the ultimate test of geological model. Now, on the surface, we can do one or two analysis from the outcrops we come across on the surface. And so geologists can decide, okay, since we are obtaining this kind of information to infer that the ore body is like this or like that. But that is just an inference, an assumption. Okay, we need to confirm that information. And the only way we can confirm is by we digging, drilling into the ground, obtain the subsurface samples, analyze it to get the actual information. Okay, so it is the information we get from the subsurface that will now confirm that what we analyze on the surface is true or is not. Get it? So the interpretations, geological interpretation and geological interpretations will need to be confirmed by our formations or the analysis of in the subsurface. That is the samples we obtain and analyze it. The information we obtain from it help us either to continue with the project or to abolish it. Provide samples for assaying the chemical analysis, methodological testings, and the technical analysis. We already know about this. So it defines the geometry, the grade distribution, the geological continuity of the ore body. So how can we know the grade of the deposit we are dealing with? And how can we know even the distribution of the deposit? Let's say uh, this is the surface and here is the ore body. Okay, we are on the surface here. How would we even know that this is the exact location of the ore body? We are on the surface. We will not know exactly where it is lying. So we need to draw down. We need to do a lot of drilling. So once we are doing this drilling, you one way intercept the ore body. Okay, you need to do drilling. So with the drilling we are doing, we obtain samples from this drill hole, obtain samples from this drill hole. When you take it to the lab and analyze it, you realize that okay, oh, this one is waste. This one too is waste. Then from here, by analysis, you will find out that from here to here is waste, but from here to here, I get some information about the deposit. Okay. Then on this drill hole, from here to here, you will find out that it is waste. And from here to here, you will find out that I'm getting some information on the drill hole. So with this, we can now get a target area. The target area can will depend on this drill, and this drill. The information we get here. With this one, we can now focus our attention and drill more holes here. Can drill more holes here. That is now we have been able to identify the target area. Okay. With this, we can now have a lot of information about the ore body. This is where we can now, with the information we obtain from the samples, can know what is the grade distribution of the ore body and what is even the shape and the boundaries of the ore body. It's very, very important. It provides the data necessary to calculate the reliable and defensible resource estimate and provides information for planning the mine layout, selecting mining methods, and also designing infrastructure.